All right, thank you. I'll put this here. I'll talk about it later. Okay. All right, just a quick one. Who here has heard about Aethir? Who here knows what we do? Anyone? One, two. My team doesn't count. Okay, cool. Well, I'll spend a little bit of time explaining what we do to get you guys up to speed. We'll talk about this little box down here as well, which is pretty cool. Little bit maybe more retail flavor here, so try to keep things a little bit kind of simple, so hopefully you understand what we're up to. Anyway, before I kick off into what Aethir does, a little bit of background about myself. My name's Mark. I'm one of the co-founders here at Aethir. I'm not the CEO. I'm the CSO. My co-founder, Dan, he's the CEO. He'll be here a little bit later on. My background's in infrastructure building. We're an infrastructure company. I started in infrastructure, actually started in oil and gas, building big energy projects in really remote places before deciding to found my first company, which is a biotech company. Worked on that for a couple of years, raised some money. Very interested in what you guys are doing, considering my background there. Before kind of feeling my way back into infrastructure, I was living in China at the time. Some very, very cool cloud infrastructure projects at play there. We took a look at some of the performance and scalability challenges that we were facing in a centralized cloud world, and realized that there was a really cool opportunity to address some of these challenges if we took a more decentralized compute approach. So what's the problem that we address? I think the best way to understand what Aethir does is to really kind of understand the problem that we solve. There is a global enterprise compute shortage. This is primarily in relation to AI, right? You've probably seen people like Elon Musk come out and say things like, GPUs are harder to buy than drugs. You've probably seen people like Mark Zuckerberg out there purchasing, $10, $11 billion worth of GPUs at a time. It's getting increasingly difficult for the non-tech giants to access these critical GPU resources and get in the race building, interesting AI products outside of essentially the walled gardens of massive tech companies. So, what does that supply shortage look like? Right? We break it down into kind of four key pieces that I think are pretty interesting to understand. First, of course, you have buy pressure, right? There is this race to AGI, this race to win that the biggest tech companies in the world are highly motivated to achieve. Essentially, they have an insatiable appetite for compute. They're purchasing out as much as they can. Traditional channels like the hyperscalers invariably are either out of stock or are charging kind of ridiculous prices and predatory contracts for anyone looking to optimize compute within their stack. Production limits, of course, these GPUs are a physical device, right, that come primarily from NVIDIA, and you can only produce so many of these chips per year, and at the moment, the number of chips required just doesn't seem to be able to catch up to the compute demand in the market. Now, why that is a little bit interesting. One of the primary compounding factors there is this LLM complexity challenge, right? LLM stands for large language model. ChatGPT 4, ChatGPT 3, these are all large language models. Now, as you go from ChatGPT 3 to ChatGPT 4, the requirements to train that model are exponentially more. Later generation models are exponentially more complex, more power intense, they require more compute power, they also require more data. And what we're seeing is that as these models get more intelligent, right, they're requiring an exponentially larger amount of resources. So later generation models require exponentially more compute than their predecessors. And we're seeing new models released every year, right? And within that same period, we're not seeing an exponential increase in compute supply. We're not seeing an exponential increase in the quality of compute being produced by companies like NVIDIA. So it looks like there's a widening gap between what later stage models will continue to need and the type of compute that we're able to access on the market as a result of what's being provided by the compute providers. But what's maybe most interesting to Aethir is this inefficiency piece. I think anyone that's run large hardware ecosystems is aware that utilization and maintaining high utilization of your equipment is key to profitability. It's key to minimizing the financial impact that that compute has on your network. And this is the most expensive compute of all time, right? So optimization and utilization within that network is critical. And unfortunately, it's not something that very many companies are actually all that good at, right? We did a study, we looked at all the data centers across the US, and actually enterprise-grade GPUs sit idle almost 80% of the time, right? So there's actually a large amount of compute that exists out there, most often purchased by companies that have no infrastructure to on-sell that compute. They're buying compute for themselves, right? So if they miss forecast, if they have a production delay, all of a sudden that compute is burning a hole in their pocket. And this is the biggest hole that you can kind of have from a compute perspective. So we took a look at this and we said, what if we could effectively create the Airbnb for enterprise GPUs? What if we could create an infrastructure layer that was very, very simple, super easy to access, and it gave these companies the ability to reconnect their compute with the global compute demand ecosystem, right? Redistribute that kind of lost supply that exists within companies that don't have the ability to push that compute out that they've purchased internally, and what would that look like? So that's effectively what we built. We built a decentralized enterprise-grade GPU cloud infrastructure for AI and gaming companies. We aggregate compute from tech companies, enterprises, data centers, big crypto mining farms, anyone that has the type of compute that's useful within our network, we'll aggregate and we'll make it very, very, very easy to access that compute at a significant discount, and effectively it's net new supply in the market. It's a quick infrastructure diagram. You can see the enterprise data centers miners contributing up into our enterprise suitable GPU stack, which makes up the Aethir cloud. So what does the product look like? If you've ever had to buy compute, this will be super familiar. We're not trying to make things too Web3 crazy, right? Effectively, if you're on the buy side, you come on, you choose what GPUs you want, how many you want, what region you're in, and you purchase that compute. The main difference here is that you purchase the ATH token and you use the token to buy the compute. If you're on the compute provider side, instead what you'll do is you'll effectively download connect to our APIs. The network will accept your GPU usually within about 15 minutes, and as long as you pay the staking fees, your compute is up and live on the network essentially instantaneously. Obviously, if you're a retail investor, you can effectively look at the ATH token as exposure to AI infrastructure, right? If you're going and you're buying AI infrastructure in the public market in Web 2, you can't buy AWS stock. You can't buy Google Cloud stock, right? You can only buy into Google, you can only buy into Amazon. They're diluted by a huge number of other product lines within the business. This is kind of direct exposure to AI infrastructure on a global level. So what makes Aethir different? Who here knows what DPIN is? Cool. All right, so DPIN stands for Decentralized Physical Infrastructure Networks. It's essentially blockchain-based ecosystems that have like a physical presence in the real world, like Filecoin, for example, with their storage servers, right? Aethir, we have GPU compute all over. So we're a DPIN in the compute space. But what makes Aethir different is that we are 100% enterprise focused, right? The trend within DPIN, at least early on, was to aggregate consumer compute. Take gaming PCs, take MacBooks, right? And pull that compute, those GPUs into your network such that you have a large number of, obviously, GPUs committed to your ecosystem, but at the same time, you also have a large number of people that are highly motivated in your token doing well, right? Because all of a sudden, if you've contributed your gaming PC's idle time to that network, if that token goes well and you get paid in tokens for contributing that idle time, you're a pretty motivated community member. However, the challenge with aggregated consumer GPU compute is that it's really, really hard to sell, right? If I took everyone's laptop in this room and contributed it to a cloud, I can't guarantee that your laptop will be on at this particular time. right? Or that you won't be out of range with your laptop, or that your network won't be limited because you're watching YouTube, for example. So it's really hard to meet the enterprise SLAs of big cloud customers with a consumer compute network. And this is kind of the biggest challenge that's faced deep in, at least this cycle, and to be fair, the cycle before. So we took a look at this ecosystem. We said, who are the customers that we want to serve, right? And we wanted to serve the biggest customers in the world because those are the ones that are buying compute at scale. So we knew we needed to build an enterprise-first GPU compute infrastructure network. So that's what we did. So 100% of the 43,000 GPUs connected to Aethir are enterprise-grade. They're sitting in data centers, they're connected to enterprise-grade network infrastructure, they're serving enterprise customers. And that's a massive, massive differentiator. So these are the compute products that we have within our stack at the moment. You'll see AI training on the top left. AI training is the process of making AI effectively more capable. So from going from ChatGPT 3 to ChatGPT 4, that's the process of training, right? So we have the largest collection of H100 GPUs within Web3. We have just under 4,000 of these chips at the moment. That's a massive amount, at least in Web3. It's a small number when you look at kind of Web2 numbers, but it's certainly a big number within the Web3 space. On the top right, you'll see AI inferencing. Inferencing is the word for AI doing its job, right? So you've trained the model, and now the model has to do its thing, which is, if you're ChatGPT, respond to queries, right? That process is called inferencing. So we have a number of AI apps and AI applications that are working on the back of our infrastructure as well. We also have a whole segment of our GPU cloud that is gaming focused. And I'm going to get into this next. I think it's really, really cool. And then we have a virtualized compute stack, which is a little bit more of a corporate product. There's a cool product that's building on it called Aethir. Recommend you checking them out. Very cool stuff. But let me kind of dig into the gaming problem, because I think this is quite interesting. It was one of the core problems that we chose to address when we started Aethir in the very beginning. That is that there's 3.3 billion gamers out there, but 2.8 billion of them are gaming on low-end devices, right? They don't have access to a PlayStation 5, an Xbox, or a gaming PC. They're experiencing gaming content generally through their phone, and generally through a low-end phone, right? Now, that's a massive, massive issue. That means that those gamers can't access the biggest and best gaming content in the world, right? They can't play PUBG, they can't play League of Legends, they can't play all of this cool stuff that's coming out of the biggest gaming studios in the world. But it also means that those big gaming studios can't reach them, right? It's probably the biggest bottleneck within the gaming ecosystem, right? The hardware restriction as a result of low-end consumer devices. So what can you do to address this? Well, you can make everyone more rich so they can afford a phone or a PlayStation or an Xbox. How likely is that? Probably not very likely. You can reduce the cost of the chips that go into these devices and effectively democratize access to high-powered consumer equipment. Also, probably not likely, would require some form of quantum leap in chipset technology. Or you can take a technology that we already have, which is cloud gaming, right? The ability to do the processing requirements of a game in the cloud, and you fix the scalability issue. And that's what that's what Aethir allows us to do, right? So we talked a little bit about the AI side, but on the gaming side, we make cloud gaming or real-time rendering technology scalable because we build it on the back of a decentralized compute network where we don't have that massive upfront compute cost that you need to overcome when you're deploying this into a new region, right? And there's a couple of really cool advantages to distributed compute networks. If you're a centralized compute provider, you have a huge set of economic benefits for putting your compute in one place, right? You put it under one roof, you have a small team to manage it. It's the most efficient way to manage your inventory, right? But it also means that the further a user gets away from that compute, the worse their performance, the higher the latency of the network. Because latency within this type of ecosystem is very directly proportional to how far away you are from the compute physically in the real world. So if you have a distributed compute network where I'm an owner of compute and you're an owner of compute, there's no incentive for us to put that compute under the same roof. So by definition, even when it's just two providers, right? I've created an ecosystem where it's more likely that a user within that network will be closer to someone that's providing that compute. And then as the network grows, you again have no incentive for that compute provision to be adjacent to any other compute provider. So you have this incredibly cool alignment between the performance of the network and the scale of the network that you only see in decentralized systems. So some recent highlights. We did a massive node sale. If anyone's interested in doing a node sale or getting advice on node sales, we have a team that helps with that. We can introduce you, of course, to the full cohort of node buyers within our network to help you bootstrap your own. But this was a very, very cool process for us. We're actually live as well. Our token went live in June. And actually, we just got listed on Upbit and Bitstamp just a couple of weeks ago. So fully live in Korea too. So, you know, all the Korean degens, let's go. This is my chance to talk a little bit about Aethir Edge. Who here has a node? Did anyone buy any nodes from any of the kind of node sales that have been kind of going around? Who here is a DPIN, is a little bit more of a stretch. Who here has ever owned a DPIN device? Call it like a Helium device or a Bitcoin miner. It's a little bit niche, but I see a few people. Anyway, one thing that's really, really cool about DPIN, similar to the topic that I just spoke about with regards to lowering latency within networks, right? The edge, right? Edge computing, it's a term for computing that happens as close to the users as possible. Edge computing is a really cool frontier for a lot of different verticals, but it's an incredibly difficult segment to optimize for, right? For two reasons. First of all, if you need to put specific types of edge infrastructure into different environments, it's usually very, very expensive, right? You'll have to kind of use these modular micro data centers, install things in weird locations. It's obviously an expensive place because where the users are, the cost of having infrastructure is usually quite expensive. It's outside of very specific use cases, it's almost never cost effective to do edge infrastructure work, right? But there's a whole bunch of latent compute out there in consumer devices on the edge. And that's really interesting, but the difficulty there is that there's so much diversity in that compute, right? Your computer is different to your computer, your network's different to your network. It's really hard to kind of optimize for anything and create this kind of uniform, sellable service. So what can you do? Well, you can create a uniform compute layer that provides rewards to the owner, and you can put it in people's houses, and it can operate as essentially a passive compute node that's taking advantage of being on the edge. So that's what the Aethir Edge is. It's effectively an enterprise-grade compute node. We partner with Qualcomm, it's got their latest AI chip inside, and it effectively operates as an edge-capable enterprise compute node for agent-based infrastructure, for real-time processing, anything that benefits from extreme low latency environments will benefit from this. So thoroughly recommend, if any of you are interested, check out myedge.io, where we're currently selling the edge nodes. But yeah, that's all from me. Thank you very much. Appreciate your time.
Thanks so much for an amazing speech.